Welcome to our guide on mastering EViews workfiles. This session is designed to cover the foundational skills of structuring economic data for analysis. As the EViews user guide states, the very first step in most projects is to read your data into an EViews workfile. This is the gateway to all economic analysis within the software. This deck covers the foundational skill of structuring economic data for analysis. This slide illustrates the data container problem in EViews. Raw data, often chaotic and undefined in formats like Excel or text files, cannot be directly analyzed by EViews. The EViews workfile acts as a crucial container, functioning like a funnel that imparts structure to this raw data. This structure is defined by elements such as frequency, which relates to time, and identity, which relates to cross-sections. Once processed, the raw numbers are transformed into intelligent economic objects within EViews, such as series, groups, and equations, which are then ready for econometric analysis. It's essential to understand that EView cannot analyze any data without it being housed within a workfile. A key formula to remember is data plus structure equals a workfile. Within a workfile, there's a distinction between the range, which represents the total capacity or full period of the data, e.g. 1950 to 2020, and the sample, which is the active subset of that data being used for analysis, e.g. 1990 to 1995. This decision map guides you through choosing the correct data structure for your analysis. First, ask yourself, what does your data look like? If your data is a snapshot random sample with no time dimension, then you have unstructured, undated data. If your data was measured over time, then the next question is, multiple entities? If no, and the data is at regular intervals, then your data is dated regular frequency, suitable for time series analysis. If you answered yes to multiple entities with data measured over time, then you are dealing with a balanced-unbalanced panel data structure. These are the big three data structures. 1. Dated. This is for time series analysis, like GDP or CPI data. 2. Unstructured. This applies to cross-sectional analysis, typically from surveys. 3. Balanced panel. This is for pooled time series, such as tracking firms over several years. A crucial piece of advice: choosing the wrong structure limits your analysis options later, especially for techniques that rely on time, like lag operators. Method A is manual creation. You go to File, New, Workfile, define the structure or shell yourself, and then type or paste the data in. This method is really only suitable for very small datasets or simulations. Method B, the far more common and recommended approach, is foreign data import. You use File, Open, Foreign Data. EViews is very intelligent and can often auto-detect the structure directly from files like Excel, CSV, or Stata. We strongly recommend using the Open Foreign Data method for over 90% of tasks. It significantly reduces the risk of human error, especially when defining complex date structures. And don't worry about getting it perfect the first time. EViews is flexible. You can always restructure a workfile later using the Proc Structure menu. For a class project with 10 data points, manual creation is fine. For your thesis, using 20 years of quarterly data for 50 countries, you absolutely want to use the foreign data import method to avoid mistakes. To better understand how EViews handles these structures, let's briefly look at the underlying mathematical logic. For time series data, the logic is simple. Each observation is indexed by a single time subscript, yt, where t goes from 1 to t. To define this, EViews needs a start date, an end date, and a frequency, like annual or quarterly. For panel data, the logic expands. Each observation is indexed by two subscripts, yit, where I represents the entity from 1 to n, and t represents time from 1 to t. To define panel data, EViews needs two key series, an identifier series for the cross-section, like a country code, and a date series for the time period. The combination of these two identifiers is called the panel key. This key must be unique for every single row of data. For example, the combination of USA and 1990 must point to only one observation. Regular frequency data has consistent, even gaps between observations. This is the standard for most macroeconomic data, like annual GDP or quarterly CPI. Irregular data, on the other hand, has uneven gaps. A classic example is financial tick data, where trades can happen milliseconds apart and then not for several seconds. The main risk during import is that EViews might try to treat irregular data as regular. If it does this, it can interpolate missing values or completely misalign the dates, corrupting your dataset. Therefore, you must always validate the import. EViews will try to auto-detect the frequency from an Excel file, but if your data has missing periods, like weekends or holidays for financial data, you must double-check the date series setting to ensure correctness. If you import daily stock prices, but your Excel sheet omits weekends, telling EViews it's daily regular frequency data is wrong. It will misinterpret Friday's data as being immediately followed by Monday's, ignoring the 2-day gap. This idea of unique identification is also central to panel data, so let's look closer at panel identifiers. When working with panel data, understanding how identifiers function is crucial. On the left, you see a balanced panel, represented by a complete grid of blue squares. This signifies that for every country, across all years, we have observations. In contrast, an unbalanced panel, shown with missing gray squares, indicates that some countries might have missing data for certain years, or some years might have missing data for certain countries. To properly structure your panel data, EViews uses valid identifier types, such as integers like 1, 2, 3, strings, for example, firm A or firm B, or even specific dates, like January 1, 2020. Now, let's look at the critical rules. First, a fundamental constraint. You must have a unique cross-sectional ID and a date ID. The combination of these two must uniquely identify each individual observation in your dataset. For error prevention, EViews is designed to trigger an error if these IDs are not unique per observation, preventing data integrity issues. Finally, the distinction between balanced versus unbalanced panels is whether every entity has data for every period. A balanced panel ensures a full rectangle of data, while an unbalanced panel has gaps. To navigate EViews, you can follow the breadcrumbs, which are the menu paths. The recommended path for importing foreign data is File, Open, Foreign Data as Workfile. There's also a manual path, File, New, Workfile. A handy shortcut for quick access is to right-click the empty gray workspace area and select Open Foreign Data. For those who prefer command line efficiency, the syntax for opening a workfile is WF Open, and for creating a new one, it's WF Create. At the top, you have the button bar with common actions like View, Proc, Save, and Gen. Below that, you'll see the range, which indicates the total capacity of your workfile, the start and end dates for all observations. The sample shows the currently active subset of the data. By default, it's the same as the range, but you can change it to focus your analysis on a specific period. The main area is the object directory, which lists all the objects in your workfile, like series, groups, and equations. Pay attention to the permanent objects C for the coefficient vector and resid for residuals. You should never delete these. The icons tell you the object type, a small graph for a series, a G for a group, and a beta symbol for a coefficient vector. If your workfile range is 1950 to 2020, you could set the sample to 1980 to 2000 to run a regression using only data from that specific period. Now let's put this all together in a practical case study, starting with importing data from Excel. Our scenario is to import GDP and M1 money supply data from 1952 to 1996 from an Excel file. The fastest and easiest action is to simply drag and drop the Excel file onto the EViews workspace. EViews will then launch the import wizard. A crucial tip is to ensure your Excel file is clean, with variable names in the first row and data starting immediately in the second. If the file is messy, you'll need to manually specify the exact data range, like A1 to C50. During the import process, EViews will ask if you want to link the series to the external source. A dynamic link means the EViews data will update if the source Excel file changes. A static link creates a snapshot, which is better for reproducibility, as your results won't change if the source file is later modified. This slide covers the second step of our case study, structuring and linking data within EViews. On the left, you see the Workfile Create dialog, where dated regular frequency is selected as the structure type, and annual for the frequency, which is typical for standard time series data. A critical decision during data import is whether to link the series to the external source. The dialog box offers yes for a dynamic link and no for a static link. The linking decision section explains the rationale. A dynamic link is useful for ongoing reports, where the source data frequently grows or changes. Conversely, a static link is essential for reproducibility, ensuring your results remain unchanged even if the original source file is later modified, which is crucial for academic research or reports requiring fixed outputs. Once imported, you must perform a sanity check. First, verify the data range. Did EViews correctly identify the start and end dates? In our case, 1952 to 1996. Next, check the series list. Are all your variables, like GDP and M1, present in the object directory? Most importantly, check the actual data values. A common pitfall is that EViews might import empty rows from the bottom of your Excel sheet as zeros. Scroll to the bottom of the spreadsheet view to verify this didn't happen, and ensure there are no NA values in critical rows. A powerful tool for comparison is the group view. You can select multiple series, right-click, and choose Open as Group to see them side by side in a spreadsheet, making it easy to spot inconsistencies. Here's a power move. For complex panel data, it's often safer to import the data as unstructured first, then define the structure using proc structure. This approach helps ensure that complex data is handled correctly. When defining the structure, you will set the Workfile structure type to dated panel and ensure your cross-section ID series and date series uniquely identify each entity. The image shows the Workfile structure dialog box, where dated panel is selected, and ISO code is entered for the cross-section ID series and Y for the date series. This conversion turns an unstructured import into a smart panel. This slide details how to interpret panel output in EViews, focusing on the Workfile dimensions. As you can see from the EViews window on the left, this is a panel workfile named PWT61EXT. It's structured as panel annual, with indices of ISO code for cross-sections and date ID for time. The panel dimension is specified as 208 entities by 51 time periods. This means the range is from 1950 to 2000 across 208 cross-sections, totaling 10,208 observations. The range format for panels is generally given as start date, end date, X number of cross-sections. On the right, under Panel Dimensions, we highlight three key aspects. First, for transformation, EViews automatically sorts your panel data by its ID and date. Second, for a visual check, always confirm these details at the top of your Workfile window. This ensures your panel is correctly structured. Finally, regarding output, once your data is in a panel format, the spreadsheet view will no longer show generic observation numbers. Instead, it will display meaningful labels like USA 1950, making it much easier to identify specific data points within your panel. This slide provides a cheat sheet for essential EViews command codes. We'll cover 4 key commands. First, to create a new annual workfile named MyData, spanning from 1990 to 2020, you would use the command wfcreate, in parentheses, wf equals MyData, page equals annual, A 1990-2020. Next, to open an existing Excel file, for example, gdpdata.xlsx, located in the C/data directory, you'd type wfopen c/data/gdpdata.xlsx. To save your current workfile, perhaps as project v1 in the C/data folder, the command is wfsave c/data/project v1.
Finally, to set the active sample range of your workfile, for instance from 1990 to 2000, you use sample 1990-2000. On the right, you'll see common frequency codes, A for annual, Q for quarterly, and M for monthly. The primary reasons to use code over clicking through menus are efficiency and reproducibility, especially when saving your commands in a program.prg file. For quick one-off tasks, you can type these commands directly into the command window in EViews for instant execution.
Thank you for joining this presentation on EViews Workfiles. We hope you now understand that the structure of your workfile is fundamental, as it determines the types of questions you can answer with your data. Our primary